I know Lucian got it, Jason kind of got it.
I fixed it.
You fixed it? I love it. That means you showed so much work that you were able to go back and see what you did wrong. That's amazing. That's why we show our work, you guys. Go back, figure out our mistakes, and learn from them. Okay. You guys ready to work this out together? You don't know? Does anybody want like 30 more seconds to try to finish it because they think they're getting it? Okay. Maybe 30 seconds to a minute. I might just come around and peek at your work just to see how it's going. You got it, girl.
Oh.
You found your mistake, Gavin?
Yeah, I think I did.
Good job. All right, let's do this. You were the first one to get it, right? Do you want to help me through it? No? Okay. Does anybody want to help me through it? Okay. He said he doesn't. Go ahead. What is the first thing that we do?
Oh, I did 12.
Oh, you did 12? Okay. Well, that's great. Can anybody help me with number 11? Nobody? Did you got it right now?
Yeah.
Okay, don't worry. Nobody can see you.
You multiply 5 times 3.
Good. What are, we're using the, what property? Distributed property. So I always make my arrows every single time. If I do it, you should do it. Now, remember on this one, I circled my 2 with the negative because I want to keep it with its sign. But here we're dealing with a positive 5, so we're not really going to mess up on that sign, right? So go ahead, Hannah, tell me what this would be. 5 times 3q?
15q.
15q.
50.
So it's a 5 times a
Negative 10.
negative 10, so what is it?
Negative 50.
Negative 50, very good. Now the parentheses are gone, and then we just have to fill in the rest. Minus 5q equals negative 15. What's our next step?
Combining like terms.
Very good. And before I combine like terms, I want to circle each term with its
Sign.
with its sign. Very good. So if you guys, this is like the only time I'll allow you to like use a pen or like a different color something or even a highlighter. So if you want to use something a different color, that's totally fine. The 15q didn't have a sign, so we know that it's positive. The 50 is negative, so I'm going to circle that. The signs are always to the left of the term. So I'm going to circle this negative 5q. Tell me what terms can be combined.
15q and negative 5q.
Very good. What do we get with a 15 and a negative 5?
Negative 20. Wait, positive 20. Wait.
Did you, I didn't hear what you said. It's okay. It's okay if you want to take a second to check your work. Or if somebody wants to call it out, that's fine. 15 and negative 5.
Positive 20q.
10q.
Oh.
Who said that?
10q.
Thank you. 10q. 15 plus negative 5. Remember guys, 15 plus negative 5. Did everybody catch their mistake? Is that what you did wrong? Okay, remember our rules when we are combining a positive and a negative number. That means we find the difference of the absolute value. So that means we forget about the signs for a second and we just find the difference of 15 and 5, which is 10. Then we take the sign of the bigger absolute value, which is 15. So that's positive. So we have a positive 10. Hooray! Positive 10q. That's really important. Then, just to keep things organized, I cross out Not so that you can't read it anymore, but just so that I know it's done. So I have my positive 10Q and my negative 50. Can it be combined with anything else?
No.
Nope. So I just have my negative 50, which is 10Q minus 50, equals negative 15. Next step.
You add 50 to both sides.
Yes, I love it. Add 50 to both sides. Cancel. Then we have 10Q equals negative 15 plus 50. Don't forget about our rules. Negative 15 plus 50, or negative 15 combined with a positive 50. What do? We take the
35.
very good. The difference of the absolute values, so we subtract 15 and we subtract 50 and 15 to get 30, and it's positive because the greater absolute value is positive. So we have positive 35. And then, what's the last step?
Divide 10 by
Divide by 10 on both sides. I love that you guys are saying on both sides. And then we have Q equals 3.5. See, I told you it was a decimal, but it's not a scary decimal. And some of you even got that answer, plugged it back in, and confirmed your answer before I even had to, which is really, really good. And we still have time left. So we're going to start with one of our word problems. I want you guys to do number 13. We talked about the sum of consecutive integers. Last week, I want you guys to try this one on your own, okay?
Fiddlesticks.
Were you still copying? It's okay. If you were still copying and I erased it, guess what? It's on video. So now you can do it all over again. All right, we're doing number 13. We have about 5 minutes to do it. So let's do it. Yes.
The first video you emailed us, it's not blocked.
It's not? You were able to watch it? Awesome. I think IT unblocked it. All right, everybody focus, focus, focus. Number 13. If you want to underline the key words to make sure you are knowing what you're doing, when you underline some keywords, make sure you know the definitions of those keywords. I'm going to bring it up to the top. And if you get it and you want me to come check your answers, let me know.
Me.
Just don't shout it out, okay? You've already got it? That is correct. Very good. That is correct. Very good. You guys are getting it.
Oh.
You're just one off. Are you trying to figure out where to start? Okay. Were you here when we went over one of these problems? Okay. If you guys want to take a look at your notes from when we took notes from lesson 1.1, we have a lot of notes. We had the example from the book was a question that was just like this. Then we had the try it problem that added a little twist. What was the little twist that it added on that try it problem? It asked for 3 consecutive odd integers. This one is keeping it simple, just 3 consecutive integers. Somebody give me an example, a really easy example, low numbers of 3 consecutive integers. Yes?
What would be?
1, 2, 3, I love it. Give me another example of 3 consecutive integers.
4, 5, 6.
4, 5, 6, good. So we could just keep naming and naming and naming. There are 3 consecutive integers that add up to 78, and there is an algebraic equation that we can set up to figure them out. Since we don't know any of these integers, any of them, it could be 9, 10, 11, it could be 12, 13, 14, probably not, because that's not going to add up, right? It's going to be a little bit higher, right? But we're not, instead of just keep guessing and guessing and guessing, we can set up, okay, we don't know any of the 3, so let's just take the first one and call it
X.
X. And if the next one is consecutive, it means it's just one higher, right? So we can call that second one what?
X plus
X
1.
plus-
X plus 1. And then that third one we can call
X plus 2.
X plus 2. Explain to me why the third one is X plus 2 and not X plus 1 again. Yes?
Because it's coming off the X, so that.
You're right, because we're representing the value in terms of X. So we're taking this number, which is plus 1, so that would be a total of plus 2. So here's our first integer, our second consecutive integer, and our third consecutive integer. It says the sum of these is 78. So we're going to combine everything to be 78. Now, what do?
3x plus 3.
Yeah, combine our x's. X plus x plus x is 3x. Add your 1 and your 2. So you have 3x plus 3 is 78. Next.
Subtract 3 from both sides.
Perfect. I see that little mistake that you made with the 78. You just forgot to subtract, right? So 78 minus 3 is 75. And then we have 3x equals 75.
Divide 3.
Divide by 3 on both sides. Cancel, and we have x equals
25.
25. Now you're going to want to go, yay, I got the answer. Let's go to the next question. I'm going to type it in, and then it's going to say wrong. Even though x is correct, what did it ask for? The three integers. So what do we have here? So it's going to be 25, 26, and 27. You guys are awesome. You can pack up and start heading out. They're following you. You can press end.